Prove that the angle between the tangent and the side of a circumscribed triangle is equal to the opposite internal angle of the triangle. And this is also the alternate segment theorem, which can also say that the angle between the tangent and a chord is equal to the angle in the alternate segment. So how do we prove that? We first start with drawing a circle, obviously, and then the tangent, and then the triangle. Okay, and then the center O of the circle, and then I name the points A, B, C, the triangle, M and N, the ends of the tangent. And what we have to prove is angle CBM. So angle CBM would be this, and that equals angle CAB, and also angle ABN, so that's this angle, equals angle ACB. And so I then first assume that angle CBM equals x degrees, and let angle ABN be y degrees. Then I draw the diameter, which is BOP, and then I join AP. And then what I would do is I would write that angle PBN is 90 degrees. So PBN is this angle. As you can see, this is a 90-degree angle. That's because the tangent makes a right angle with the radius. OB is the radius. So that's 90 degrees. The next thing is, in triangle PBA or APB, you see angle PBA would be y minus 90 degrees, because this thing is 90 degrees and the whole thing is y. So this little angle here would be y minus 90 degrees. And angle PAB would equal 90 degrees, and that's because it's the angle in a semicircle. And angle APB, therefore, which is this angle, and therefore that angle would be 180 minus 90 plus y minus 90. So this is 90 degrees plus y minus 90 is angle PBA. So that's angle APB, and that would mean angle APB is 180 minus y. So it's this angle that's 180 minus y. And the reason, of course, yes, 180 minus y. Now you see CAPB is a cyclic quadrilateral. So CAPB is this one. CAPB is a cyclic quadrilateral. I went the other way. I should have gone CAPB. But anyway, CAPB is a cyclic quadrilateral. And what happens, therefore, is the opposite angles would add up to 180 degrees. And therefore, angle ACB would be 180 minus 180 minus y, which would give you y, because the 180 and 180 would cancel out and this y would get a positive sign. So angle ACB would be y. And you see our proof is done. So we have proved the one of the angles, angle ABN, equals angle ACB, and that's proved. So now for the next part. So we leave the rest of it as it is, and we look at angle PBM. So if you look at angle PBM, so this is the angle PBM, and you see that's 90 degrees. Because same reason, radius makes 90 degrees angle with the tangent. So PBM would be 90 degrees. And therefore angle PBC, which is this angle PBC, it would be 90 minus x, because this whole thing is 90 and this bit is x. So it would be 90 minus x. And therefore So what we can do is angle PAC. So this is angle PAC is this angle. So angle PAC would be, we found out this. So these angles would add up to 180 degrees. So angle PAC would be 180 minus 90 minus x, and that is 90 plus x, because CAPB is a cyclic quadrilateral. And therefore angle CAB, so which is this bit, CAB, and that would be, because this we know that this is 90 degrees, right? So because angle BAP is 90 degrees, so if I say this is 90 degrees, we already know that this is 90 degrees, so the angle CAB would simply be the whole angle CAP minus 90 degrees. So we can say it is 90 plus x, CAP or PAC is 90 plus x minus 90 degrees, and that equals x. So the second part is proved as well. So angle CAB is equal to angle CBM, and that's x degrees, and that's proved. So that proves our theorem.